guys, this video today is all about how we get from diagrams to being able to deduce the formula of a compound. So let's get going. The first thing that we need to look at is whether the compound that we're looking at is ionic or covalent, because we treat them in slightly different ways. So let's look at these two examples here. Hopefully what you can see is the one on the left here is got a carbon and a hydrogen, both of which are non-metals. So that means that this one is definitely covalent. The one on the right has got sodium and chlorine in it. One is a metal, the sodium, and the chlorine is a non-metal. Therefore, the bonding between these guys is ionic, so very different, and therefore we treat the formula in a different way. Let's have a look at the covalent ones to start with. For covalent compounds, what we look at is something called the molecular formula, which tells us exactly which atoms we've got present in the compound and how many we've got of each. So basically, for covalent compounds, all you need to do is count up the atoms. For this one here, you've got two types of atoms, two elements. You've got carbon, which is a capital C, and hydrogen, which is a capital H. Hopefully you can see you've got 4 hydrogens here, so we add the little 4 at the bottom here like this to indicate the formula here, and it's as simple as that. For ionic compounds, it's a little bit different because the structure is giant. What I mean by that is you have the lattice structure, which can go on and on and on forever. So we can't just count the number of atoms because there would be a ridiculous number of atoms. So what we do instead is we take the simplest ratio of the elements in the ionic structure. And that ratio tells us roughly in any structure how many of one element I'll have versus the other element. So if you look at this structure of sodium chloride that I drew earlier, what you should be able to see is that I have 6 sodium ions and I've got 6 chloride ions. So what that means, it means there's the same number of sodiums as there are chlorides. These are therefore in a 1-to-1 ratio, so I can just write the formula as NaCl, showing that 1-to-1 ratio of those elements. Don't forget, this is all because it's a giant structure. There's not really 1 sodium and 1 chlorine, there's loads of them. I'm just showing the ratio. This example is a little bit complicated. What you can see here is that this compound now contains 3 different elements. You've got carbon, hydrogen, and oxygen. So I definitely know they're going to form a part of my formula. Because all of them are non-metals, that means this is a covalent compound, so all I'm doing is adding up however many of each atom that I've got. So if you look here, I've got 3 carbons, so I'll add the 3 to the formula. The hydrogens, I've got 8, so adding 8 to the formula, and the oxygens, I've got 1, so that means I don't need any number at all, because if it's there, we assume that means 1. So the formula is C3H8O. Now it's your turn to have a go at something tricky. I genuinely mean it. Really pause the video here, double check that you can do this one. Don't miss the fact that at the start they've told you it's an ionic compound. You know what to do. So, should we go through this? With ionic compounds, what you're looking for is the simplest ratio. So let's work out what the ratio is to start with. So for the aluminium, I've got 8 of them. So all the black ones, if you count them up, there's 8. The fluorine, there are 24 of those green circles representing the fluorine. So that means I've got a ratio of 8 to 24. That is definitely not the simplest ratio that I can find for those 2 elements. If I divide both sides by 8, I get a ratio of 1 to 3, which is the simplest ratio. Don't forget to put it into a formula, so that means there's 3 fluorines for every aluminium. So this looks like AlF with a little 3 at the bottom to show there are 3 fluorines. Great job. Hopefully you feel a bit more confident in being able to go from the random formulae or diagrams that they give you to being able to generate an actual chemical formula for any compound they give you.